Hello and welcome to the final video looking at the Q10 2015 May paper. So we're up to the very last question and we've got a curve y equals f of x which passes through this point 4, 9. Given that the f dash of x, so the first differential, is equal to this, we need to find the original f of x, giving each term in its simplest form. So although it doesn't say, a really common mistake here is that we're going to have to integrate. It doesn't tell us exactly to do that, but they give us the first differential and they ask us for the original, and they also give us a point on the actual line. So that means we're going to be able to differentiate and find the plus c. So first thing we really need to do is rearrange this into a bit of a nicer form so that we can differentiate it easier. So f dash of x is equal to, I would make this 3 over 2 and then x to the power of a half, which is the same as square root. Sorry, the half's a bit messy there. That's better. And the next one is going to be 9 over 4, and it was over root x, but we could write that as x to the minus a half, like that, and then plus 2. Cool, so now we're ready to integrate. I remember when we integrate, we add 1 to the power and then divide by the new power. So f of x is going to be equal to 3 over 2x. Add 1 to the power, so we're going to divide by 3 over 2, and we're going to get to the power of 3 over 2. Let's write that a bit neater, 3 over 2. And then that's going to be subtract 9 over 4 x to the power, add 1 to the power, would be to the power of a half, and then divide by a half, plus, now when it's just a constant on its own, we add an x, and finally a plus c. So we really need to simplify this a little bit. I left it like this just so we can see what we're dividing by. So the first one we got 3 over 2 divided by 3 over 2, so they're just going to cancel out. So it's going to be x to the 3 over 2. The next term, if we're dividing by a half, that's the same as timesing by 2. So this would be the same as 18 over 4, x to the half, plus 2x plus c, as it is. We could also make this 18 over 4, 9 over 2, just to cancel it down, but I'll leave that as it is for the moment. We've now got the point 4, 9, so we know x is 4 and y is 9 at some point on this curve, so we can sub those in, 4 and 9. So we're going to have x equals 4, and f of x at that point, so f of 4 is equal to 9. So we can sub that in, so 9 equals 4 to the power of 3 over 2. Like I said earlier, I'll make that 9 over 2 instead of 18 over 4. 4 to the power of a half, plus 2 lots of 4 plus c. Remember, we're trying to work out what that c is. So 9 equals 4 to the power of 3 over 2. That means you square root and then cube. The square root of 4 is 2. 2 cubed is 8. Plus 9 over 2, and then just square rooted this time, so that's 9 over 2 multiplied by 2, plus 8 plus c, nearly there. So this will be 9 equals 8 minus 9 over 4 times 2 is going to be 9 over 2, plus 8 plus c, because if we times it by 2 it gives us 18 over, why did I change that to a 4? Ugh. Apologies, that should be a 2, which means when we expand it out we'll just get 9. There you go, even I make mistakes sometimes. There we go. So 8 plus 8 is 16. So we're going to have 16 minus 9 plus c. So that's going to be 9 equals 16 minus 9 is 7 plus c. So take away the 7, 2 equals c, which means we can rewrite f of x as f of x equals x to the 3 over 2 minus 9 over 2 x to the half, that's half there, plus 2x plus 2, now that we know that c is 2. Cool. And the next part. The point P lies on the curve. So we don't know what the point P is, but we know it's on the curve. The normal to the curve at P is parallel to the line y 2y plus x equals 0. So we know the normal has the same gradient as this, and we also have the differential, which is going to give us the gradient. So probably the first thing to do is to rearrange this bit to get it in terms of a bit of a nicer form. So if 2y plus x equals 0, then 2y equals minus x, so y equals minus half x. So that means the gradient of the normal and the gradient of this line is going to be minus a half. So we know if that's the gradient of the normal, then the gradient of the tangent that we're going to use in a second is going to be 2, because if the gradient of the normal is minus a half, then the tangent is minus 1 over that. So minus 1 over minus a half is positive 2. Okay. So if we know the tangent, the gradient of the tangent is 2, and we have f dash of x, we can use that to find what the x value would be. So we know f dash of x is what they gave us at the beginning, 3 root x over 2 divided by 2, and 9 over 4 root x plus 2. 9 over 4 root x plus 2. Okay, so if we know the tangent is 2, that means we know that f dash of x is equal to 2. So 2 equals 3 over 2 root x minus 9 over 4 root x plus 2. Okay. If I multiply everything by root x, that would mean we would end up with 2 root x equals 3 over 2 x, because I'm multiplying by root x, remember, minus 9 over 4, we just cancel the root x, plus 2 root x. And now I can actually just take away the root x, because I've got plus 2 root x here, plus 2 root x there, so minus 2 root x from both sides would give us 0 equals 3 over 2 x minus 9 over 4. Now both of these are divided by, well, that's divided by 4, that's divided by 2, so if I times both of them by 2, I'd get 0 equals 3x minus 9 over 2. Now multiply everything by 2, I get 0 equals 6x minus 9. Nearly there. So our x value would be given by 9 equals 6x. So 9 over 6 is equal to x. Probably nice to simplify that down. We can divide everything by 3. So 3 over 2 is the x value of P, which is what we were asked for the question. And there we go. That's the whole paper done.